Hi, this is Brandon Bowers from CCBC Catonsville campus, studying chemistry 123. We'll be going over an exam 1 question, number 12, which involves the heat change and state change of water. We'll be using a graph that shows the changes of heat and state of water through properties of hydrogen bonds. Water is bonded by hydrogen bonds, and they need to be heated to the point of where the kinetic energy is so high that they can escape. We were asked a question here for 10 points. Water has a heat of evaporation of 43.9 kilojoules a mole. Its heat of fusion is 6.02 kilojoules a mole. The specific heat is as listed on the right. How much heat is required to warm 105 grams of water from negative 22.5 degrees Celsius to 75.0 degrees Celsius? Show your work clearly. Watch your sig figs at every step. The table here shows us that we have specific heat values. Joules over grams degrees Celsius. Ice is 2.09, water is 4.18, steam is 2.09, and these are all joules over grams degrees Celsius. We'll have to convert our joules to kilojoules later on in the question. We'll be using two equations to solve the problem. We'll need equation 1, which is Q is equal to mass, specific heat, times delta T of temperature, and equation 2, Q is equal to N, number of moles, times the difference in heat. We'll make a graph, and we'll use the points negative 22.5 degrees Celsius, 0 degrees Celsius, and 75 degrees Celsius. We'll need to mark our points. We'll start off at negative 22.5 degrees Celsius, and that'll be your Q1, and we'll have to move to the temperature of 0 degrees Celsius because the molecules will have to be heated to that point before a state change can occur. This will be a melting point. At this point, we are at a solid state, and that will be ice since we're dealing with water. This is a melting point, which is intermediate. We'll be at 0 degrees Celsius, and that will be our Q2. Next, we'll be moving to the temperature of 75 degrees Celsius. This will be the liquid phase. Liquid water. And if we were to continue, we would reach a point where we have vapor and then a gas state. But our goal is to reach the liquid state. We're going to use Q1 to solve for the first part. Q1 is equal to MS delta T. Our mass we have from the question is 105 grams of water. Specific heat from the table at ice is 2.09 joules over grams degrees Celsius, and the difference in temperature 0 degrees Celsius because large minus small, negative 22.5 degrees Celsius. We're going to multiply these together, and when we do, 105 times 2.05 into 09 times 0 minus negative 22.5, we get 4937.625. So we have 4937.625 divided by 1,000 to convert it into kilojoules, and that'll give us 4.937. We need to convert that to the sig figs, which will be 3 because that is the lowest amount of sig figs that we have. We'll have 4.9 to the 4th kilojoules of heat. for Q1. Next we'll have to find Q2. Q2 will be found by using the intermediate step of N delta H moles over heat, difference in heat, and we'll have here the number of moles equal to 105 grams of water multiplied by stoichiometry. 1 mole of water will be equal to 18.015 grams by adding 2 hydrogens and 1 oxygen atom together, give us molecular weight. Then we'll times that by the heat of fusion, which is 6.02 kilogram or kilojoules. So we'll do 6.02 kilojoules a mole. And we use stoichiometry, grams, grams, moles, moles. We end up with kilojoules. We end up with 105 times 1 times 6.02, enter, divided by, which is 1 times 18.015 times 1, 35.087. Now we also need to take this to the third sig fig. This will be kilojoules. So we'll have Q2 is now equal to 35.1 kilojoules. We'll need to do the equation 1 again one more time because we need to go from the graph. At this point we're at melting, so we'll need to become liquid. And to do that we'll use the first equation again. So we'll have ms delta T. This time we'll use 105 grams. And then we'll use the specific heat of water, 4.18. And that will be joules, grams Celsius. We'll need to convert that later. And then we'll have the higher value of 75 degrees Celsius, which is our goal. And at 0 degrees Celsius is where we're at this point, and we'll want to be here. So we'll do the equation on a calculator, and we'll get 105 times 4.118 times 75 minus 0, and we'll have that equal to 32917.5 joules, but we need that in kilojoules, so we'll divide that by 1,000. Divide that by 1,000. And now we have 32 point, no, I'm sorry. We will not need to divide that by 1,000. Yes, we do need to divide it by 1,000. So 32.9175, and that will be kilojoules. And we'll have to make that into correct sig figs. So we will have so 32.9, and we'll have to make that 3 sig figs. We'll leave this 32.9 kilojoules, and that'll be our Q3. The final step in the process of figuring out how much heat is needed for this answer, we'll need to bring the sum of all our Q values. So here we have Q1 plus Q2 plus Q3. This will equal for us 4.94 kilojoules plus 35.1 kilojoules plus 32.9 kilojoules. And that'll give us our final sum. We'll get on the calculator and we'll figure it out. So we'll have 4.94 plus 35.1 plus 32.9, and we'll end up with 72.94 kilojoules. When we write down our final answer on the exam, we'll put it in an answer. It will ask answer, and we'll have to use our final answer of 72.9, and it'll be the sig figs, so 72.9 kilojoules. And that's our final answer.